Good afternoon, everybody in Asia. Good early morning. It's 5 in the morning in Britain right now. As Malena said, I am going to walk you through the workflows for open science implementation at my institution at the University of Strathclyde in Glasgow, whereas at the same time explaining the relevance of system interoperability for open science implementation. That will be done from a CRIS perspective. So as Malena said, I'm wearing two hats today for this presentation. My institutional one, the University of Strathclyde, and then my CRIS one, where I serve as technical secretary. Next slide, please. So I'll start by briefly introducing both of my affiliations. This is, in a nutshell, what the University of Strathclyde in Glasgow is about. It's a technical uni founded end of the 18th century. It's a medium-sized university, particularly strong in the area of research grants and contracts. So it has a very strong connection to industry in Glasgow, which is an industrial, historically an industrial city in Scotland. Strathclyde is among the 20 top research intensive unis in the United Kingdom. And on the slide, you can see that we have managed to feature on 4th place in the CWTS open access ranking for 2020, meaning that we are 4th in the ranking for the percentage of your institutional research output that gets offered open access to the outside world. This is 90% for us. I will explain later how this comes about. You may see, I mean, the slide is, the screenshot is fairly limited, but most of the top entries in that ranking are British. This is due to the policy. Next slide, please. My other affiliation, as mentioned, is technical secretary for the non-profit CRIS Association, which was founded in 2002 and is based in Nijmegen in the Netherlands. It's basically a community of professionals and bodies, funders, national offices for research information management that share an activity in the area of RIM, research information management, and CRIS systems. CRIS stands for Current Research Information System, also known as Research Information Management System. PUE is the most popular CRIS system worldwide in terms of its implementation all across the world. CRIS maintains the standard that these systems, CRIS or RIMS systems, use to exchange information, to exchange metadata, because otherwise an institutional CRIS is a silo. And it doesn't really, I will come back to this later, but it doesn't really make sense to just have your institutional research projects or your research equipment and facilities. It's ideally much more useful to aggregate at a national level, for instance, all the research equipment and facilities so that you can link to them from a bibliographic record in PUE. So two main outputs, besides the fact that CRIS has memorandum of understanding with relevant organizations in the domain, two main outputs of its activity are the SERIF data model, or the SERIF standards, that will allow this metadata information to be exchanged across CRIS systems and aggregated. And then the DRIS, as it's called, the Directory of Research Information Systems, that tries to provide a snapshot of the CRIS infrastructure worldwide. The name CRIS hints at the fact that the CRIS infrastructure is at its most mature in Europe, mainly due to the research assessment exercises that are run by most countries in Europe that force institutions to report. And this is what CRISs are particularly good at. Next slide, please. So coming back to the SERIF format, you have a screenshot there describing its structure. It's basically a set of interlinked entities. The main ones are the ones with a green background, so project, organizations, and people or persons. So research projects, researchers or authors, and affiliations. Around that, a number of secondary entities. The idea is that SERIF will be able to describe all the contextual information around the research activity carried out at an institution or in a region, if it's a regional CRIS we're talking, or at national level, if it's a national CRIS. I wanted to make emphasis on the mapping exercise below, because a Pure is already interoperable through the API. However, the API is not necessarily SERIF compliant. So a working group within the UK Pure user group took the effort to map the the Pure API to the SERIF XML model that will allow this metadata to be exchanged and aggregated by OpenAir, as I will explain in a minute. Next slide, please. Then coming to the DRIS, the Directory of Research Information Systems, for a minute, you have the screenshots on your slide. Right now it's over 750 entries, so 750 records for mostly institutional CRIS systems, although there is a number of national CRISs, regional CRISs, funder CRISs, international ones even. You can see the distribution by country on the right-hand side of the screenshot, where India is actually the top country with the largest number of CRIS systems at its institutions. Next slide, please. And then you can see the map, the DRIS map, showing that it's mostly Europe where CRIS systems are implemented and aggregated, as it were. You can also see the, this is not fully up to date, the ranking you see on the right-hand side for the most popular platforms that Pure is on top of. It's not fully up to date, as you can probably see comparing the figures in this slide with the ones in the previous slide. But we're currently implementing an API, and this is the reason why the figures are not up to date. Pure is indeed the most popular commercial CRIS software solution. There are many others though, and the comments I will make on open science implementation apply to any CRIS system. So we run Pure at the University of Strathclyde in Glasgow, and we're very happy to do so, and it works just fine for us in terms of implementing open science. But the workflows I will briefly mention can be implemented on top of any CRIS system. Next slide, please. So this is a research paper that I wrote a couple of years ago, where this science implementation strategy is summarized. You have the link to the full text, which is openly available at the bottom of the slide. And it basically describes how we use Pure at Strathclyde Uni to implement open access and to implement research data management. Next slide, please. There was a survey jointly carried out by EuroCRIS and OCLC Research in the US in order to find out, as the title of the ensuing report reads, to find out about practices and patterns in research information management. This was a global survey, and the findings included the fact that open science implementation is a relevant factor for institutions acquiring or running a CRIS system, together with reporting. So it's very difficult for an institution to keep a comprehensive list of their publications. So a CRIS is the ideal place to do this because it doesn't need to be open access. It's just metadata in principle. Next slide, please. So open science is a very wide concept. There are lots of areas for open science implementation. The main ones are open access to scientific publications, open research data, open research infrastructures, open methods, open evaluation, open education, and citizen science. All these are areas of open science. When I say I'm going to describe the open science implementation strategy at Strathclyde, I will mainly focus on open access and research data management. The other ones are on the cards, so to speak, for the midterm, but we're not really doing much citizen science at the moment, although it's an area that we're definitely keeping in mind for the future. So it's open access and research data management, what I will look into. Next slide, please. You can see there an integrated workflow that we run at the Strathclyde Library for implementing open access and RDM simultaneously, because they're all research outputs. So it's all about a conversation with authors, with researchers that get in touch with the library normally to get funding to pay for their article processing charges. And then we'd ask them to please create a bibliographic record to store the version of the manuscript that applies, normally the accepted manuscript, the full text file, the research data, potentially the software. So any associated outputs to a publication is discussed within a single conversation with the researcher. You have the workflow there, how the subsequent stages follow each other. So this is then the workflow for the integrated implementation of open access and research data management with a single conversation with authors, even if it's different staff at the library who deal with open access and open access funding specifically, and research data and software and so on. Next slide, please. So the main element that drives the success of Strathclyde in terms of the percentage of its research outputs that are available open access, as I mentioned at the beginning, are the policies. And this is the reason why most of the institutions at the top of the ranking are British, because these policies are applied across all institutions in Britain. So the key one is the first one, where the Higher Education Funding Council for England, HEFC, nowadays renamed as Research England, mandates the deposit of the accepted author manuscript into a system such as a CRIS, an institutional CRIS. If it doesn't get deposited within 3 months of manuscript acceptance, the output will not count for the national level research assessment process, the REF. So all authors will make sure that they create the records in Pure for their publications or their data, just to make sure that the papers will remain eligible for the REF, for the research assessment exercise. There are a number of other policies which I will not elaborate on. You have all of them on the slide. Next slide, please. These are a few screenshots. I presume most of you are probably running Pure, so this is not going to be anything new to you, but I wanted to make emphasis on the large amount of contextual information that a publication record, a bibliographic record for a research article allows to include. So typically you would have the title, the abstract, etc. But then here you can have a project, a research project that is acknowledged in a paper. You can have research equipment and facilities. Next slide, please. That have been used to produce the paper or the data. So this is the serif model I talked about earlier. underpinning the CRIS, the pure platform, and allowing the contextual metadata to be added to what it would otherwise be essentially a publication record. As mentioned, we have occasionally problems when papers acknowledge projects that are not run at Strathclyde. We don't have them in our database, or papers mention research infrastructures such as the one I'm showing on the right-hand side, the Flowwave facility at the University of Edinburgh, which is a really expensive, beautiful piece of infrastructure. We cannot link them. We don't have them in our database. So this is the nature of the siloed nature of the research information held in institutional CRISes. Next slide, please. This is where the concept of system interoperability comes in, where the information can be exchanged. This slide shows the institutional exchanges between a number of institutional systems and Pure in terms of delivering information. So the projects are provided from the project management system, the HR information for people come from the HR system, financial, etc. And on the way out, the information is exported to an institutional repository, such as Strathprints in our case, which is highlighted in red for the ref. So the papers selected for research assessment are again submitted from Pure, from the CRIS, and because the CRIS is able to interoperate with the research assessment systems as well. Next slide, please. More importantly, you have external system interoperability as well. And this is what the development I was talking about earlier, whereby a mapping between the Pure API and the Serif XML guidelines will allow the metadata held in the public metadata held in the CRIS to be harvested and aggregated. And this is done by the OpenAIRE platform at an all European level. You can see on the right-hand side the OpenAIRE guidelines for CRIS managers. This is the specification for this information exchange that will allow data sets, authors, publications, projects and organizations to be exported and aggregated so that we can get a really good snapshot of the research outputs and beyond carried out at a European research area level. Next slide, please. So this is in slightly more detail the project that I was talking about earlier for mapping the Pure data model to the OpenAIRE Serif XML guidelines. There was a short life working group, mostly composed by members of the UK Pure user group, also a Danish one, a member of the Danish user group. They together mapped this data model. And then as a result, next slide, please, we have Pure, the test instance of Pure in Aalborg as compliant with the OpenAIRE guidelines for CRIS managers already, together with a number of additional CRIS systems in various countries, in Serbia, in the Netherlands, in Poland, Finland, that have already implemented these guidelines. If you run Pure, you can already do this as well. And I would encourage you to get in touch with us at Eurocris. Our email is eurocris@eurocris.org for any questions on the guidelines or having your institutional system in the DRIS. For instance, Asia is not particularly well covered, save for India, as I showed. So please get in touch. Next slide and last one shows, same as OpenAIRE tries to aggregate all CRIS information and repository information across the European research areas, across all Europe and associated countries like Turkey or Israel. There is this open knowledge base, OKBNL project in the Netherlands that aims to aggregate CRIS information at a national level. Most of the CRIS, the institutional CRISes in the Netherlands are Pure. So the pure data model could be used as an exchange format, as an exchange standard. However, there are other CRIS systems as well that are not pure. There is at least one Converis in Leiden and two Metis implementations at Radboud in Nijmegen and at Erasmus in Rotterdam. So we need something vendor agnostic in terms of standard of metadata exchange standard, and this is where Serif could play an interesting role because it is in fact agnostic. So there is a proposal, in fact, for using Serif XML as an interoperability mechanism that would allow all CRISs in the Netherlands to deliver their information, their publicly available metadata into a national level aggregation or open knowledge base. Keep an eye on this project. It's really interesting. The amount of business intelligence that can be carried out on top of a national level aggregation is remarkable. Thank you. That is me. If there are any questions and I have any time left, I'm happy to take them now. Thank you.
Well, thank you so much, Pablo. And I am so sorry to say, but the time has run up. I would have loved to dig into a little bit more of the details of the scenario for the future on this here. An enormously interesting discussion or presentation. You mentioned the EuroCRIS email address. Perhaps we could put it into the Pure Community Slack for people to get in contact, and also they can contact you directly using the forum here in at the conference space. So thank you so much, Pablo, for getting up this early and doing this great presentation.
My pleasure. Thank you very much.